In today's lesson, we're going to graph simple rational functions. So we'll start off with the most basic of a rational where we have f of x is equal to 1 over x. And this is what's creates a graph known as a hyperbola. And an hyperbola is simply composed of these two branches and that are symmetrical. And within this, we have two asymptotes. The reason we have the asymptotes is that because the function is 1 over x and x cannot be 0, we'll have a horizontal asymptote right there on the x-axis located here, as well as we will have one on the y-axis vertically. Because we can't have an a value of 0 either. And this is going to be the same for all of these, no matter what our value of a is going to be, as long as it's in the same form. So, for instance, if I were to look at this, the parent function, I would see that this graph would look like this. And we can point out a few key points, like this would go through 1, 1 here, and it would also go through -1, -1 on this branch as well. So given that, we could compare this to other graphs if we change our a value. So for instance, if I were to look at this one, if I wanted to graph it, all I'd have to do is substitute values for x. So I could put in 1 for x, so thus y would equal 4, and then I could do -1 for x, and so we'd start developing these points. So like here's that 1 value right here, and so x is 1, y is 4. Or we plug in -1 and we get -4, and we can put in various other points as well. The trick is being able to find whole number points. That it's very easy to run across decimals. But notice how this one with a larger a value, I want you to notice that it seems like it's kind of stretched away from the origin. So the larger that value gets, the further away from the origin, and then the smaller it gets, or closer to 0 a gets, like 1.5 or something, the closer to the origin it gets. It tends to sweep in a little bit more. But we can also include our translations, our h and k. So again, we have our minus h directly on the x, and then our plus k for our vertical transformation. And basically, when you're graphing one of these, the first thing you want to do is you want to draw the asymptotes first. These will be your key guide as far as to what it's going to be looking, where the branches might be. And then you'll just start plotting points by substituting in values for x and then figuring out y. And once you have the points, you're going to draw those two branches. So let's take a look at one and see how that would work. So let's say I want to graph something like y equals -3 over x minus 1 plus 2, and I want to state the domain and range. The first thing I want to do is I want to find the asymptotes. Now recall our first function, the parent function, the asymptotes were on the x and y axes respectively. So now with the -1, we can see that's going to be shifted right 1, and so our vertical asymptote is going to be going to the right one. So we'll draw that in. It'll be about here. So see how well I can do that. At x equals 1, and then the plus 2 tells us that our graph is going to be shifted up 2. So thus the horizontal asymptote is going to be y equals 2. So I would draw that in like so. Now the -3 here for our a value tells us it's going to be further away from the asymptote, or further away from where the origin, or in this case where our asymptotes cross. Um, Also, the fact that it's negative tells us it's going to be reflected. So remember, ordinarily we would be in the upper right-hand side and the lower left-hand corner of our graph. But now that's going to be flipped. We're going to be in the upper left-hand side and the lower right-hand side of our graph where the asymptotes are. So let's say 0 in for x, and y equals -3, and then I'd have 0 minus 1 plus 2, so that's going to give me +3 and 2, so y equals 5. So I'd have a point at 0, 5, for instance. So I would plot that here. And that's where I expect it to be, because it's going to be flipped. It's not going to be in the upper left-hand corner, and there should be one down here. So let me try another one at, we'll say -2. So if I did -2, or rather +2, sorry, not -2, +2. So y equals -3 over +2 minus 1 plus 2. This is going to give me, let's see, -3 over 1, so -3 plus 2, and that's going to give me -1, so y equals -1. And so at +2, I get -1. So that's going to give me a point down here where I'd expect it. And so you do two points per branch is fine. You repeat that process, and once you've done that, you're going to get something that looks like this. Yeah, there we go, like this. And we can see it's going through the points I drew there. And of course, don't forget your arrows. This doesn't have the arrows, but you should have your arrows. So then we're just going to come up with our domain and range. So really, it looks like it's going to be all real numbers except where we have our asymptotes. So for my domain, I'll just say that it's going to be x is such that it's all real numbers except x is not equal to 1, where that horizontal asymptote is. And then our range, we'd say y is such that it is all real numbers, all real numbers, except y is not equal to 2. So that would be our two restrictions, or our domain and range in that case. Okay, so there are other rational functions, in the form of ax plus b over cx plus d. So you could think of it as like a linear over a linear. And to find these asymptotes, it's take a little bit more. Now, the first one, the vertical asymptote, can easily be found because we can't have a denominator of 0. So to find that, you would just have to set this denominator equal to 0 and figure out what that's going to be. So if you were to work that out, you would end up getting, let's see, that's going to be -d over c. And since it's a vertical asymptote, that's going to be x equals. So, whatever is going to set that equal to 0, you solve it, and then you get your x value. And horizontal asymptote, really is boiled down to the a and c in front of the y here. And so whatever those coefficients reduce to, if they do, it's going to be y equals a over c, and that's going to indicate to us what our horizontal asymptote is going to be. So let's look at one of those examples. So here I want to graph y equals 3x minus 6 over x plus 2. And we want to state the domain and range. So we're going to start off and find our asymptotes. The vertical asymptote, as I said, can be found simply by taking the denominator and setting that equal to 0. So thus x would equal negative 2. So my vertical asymptote would be located there, and my horizontal asymptote would be found by looking at our two coefficients here. So 3 and what looks like 1 located there. So I would say y is equal to 3 over 1 or just 3. And we'll go ahead and sketch those in. So x equals negative 2. And y equals 3. Like so. Alright, now it's simply going to be a matter of selecting some points and substituting them in and finding what the graph is going to look like. Like I said, 2 points per side will work just fine. So for instance, let's say I choose negative 4. So y equals 3 times negative 4 minus 6 over negative 4 plus 2. So y equals, let's see, it's going to be negative 12 minus 6, which will be negative 18, over negative 2. So that will be negative 18 over negative 2, and that's going to give us 9. So it'll be negative 4 and positive 9, so I should have a point there, negative 4, positive 9, which will be there, and then you would find another point. So if I have a point there, I'd expect the other branch to be on the opposite and bottom right quadrant. So I could substitute in, let's say positive 4. So 3 times 4 minus 6 over 4 plus 2, and so that's going to be 12 minus 6, which is 6, and then 4 plus 2, which is 6. So that will be 1. So that point will be 4, 1. And so I'd put that point in right here. And anywho, you'd come up with 2 points for both branches, and it should look like this. And now all we have to do is state the domain and range. So we can see we have all the x values except for when x equals 2, or negative 2 rather. So x is such that is all real numbers, except for when x cannot equal negative 2. And our range, y, is such that it's all real numbers, except y cannot equal positive 3. So there's our domain and range. So we plot our points, got our domain and range, we're good to go. So that's graphing simple rational functions. Till then, I'll see you on the flip side.